Hi everybody, and welcome to this lesson on Identity Access Management, or more commonly known as IAM. First, talk about what is IAM. Now, the Identity and Access Management is a web service that helps you securely control access to AWS resources. You can use IAM to control who is authenticated or signed in, and authorized or has permissions to use resources. So if you guys are familiar with the Windows environment, these are basically just your users that you can create that would have access to Amazon Web Services. Now, when you first create an AWS account, you begin with a single sign-in identity that has complete access to all AWS services and resources in the account. This identity is called the AWS account root user, and is accessed by signing in with the email address and password that you used to create the account. Now keep that in mind, because sometimes the Cloud Practitioners exam will ask you about the credentials more commonly known as a root user. So basically know that they have complete control over the entire AWS user account. And it's strongly recommended that you do not use the root user for your everyday tasks, even the administrative ones. Instead, we have to adhere to what AWS has created in terms of IAM users and IAM policies, and that way you can securely lock away the root user credentials and use them to perform only a few account and service management tasks. Now, you can also integrate IAM policies and permissions with directories you already manage. For example, the Microsoft Active Directory or the AWS Directory Service or OpenID, Connect Provider, and so on. That's more commonly known as federated access. And again, we'll also discuss federated access a little bit later on, but again, it's also a key exam term. So there are a number of features that IAM gives you. For example, it gives you shared access to your AWS account. You can grant other people permission to administer and use resources in your AWS account without having to share your password or access key. You can grant different permissions to different people for different resources. For example, you might allow some users complete access to an Amazon EC2 or a Amazon S3, which is used for storage, or any database or any other AWS services. For other users, you can allow read-only access to just some of those resources. For example, if you have data on AWS stored in a S3, you can allow some users full control, while others you can allow read-only access. You can secure access to AWS resources for applications that run on Amazon EC2. You can use features to securely provide credentials for applications. These credentials provide permissions for your applications to access other AWS resources. So again, just keep in mind that an IAM user can be a physical person or it can be an application. They also support multi-factor authentication, or MFA. You can add two-factor authentication to your account and to individual users for extra security. It also has identity federation, which I just discussed a little bit ago. You can allow users who already have passwords elsewhere, whether it's Facebook, whether it's Microsoft Active Directory, to get temporary access to your AWS account. It also has PCI DSS compliance. It supports the processing, storage, and transmission of credit card data by a merchant or service provider, and has been validated as being compliant with the payment card industry or PCI data security standards. So if anything is compliant with the PCI DSS, you can rest assured that it has extremely strong security because it's been certified to handle credit card information. Now, you can work with IAM in a number of ways. For example, you can access it through the management console, which is a browser-based interface which we looked at. And after this lesson, we'll go ahead and log back in and see how we can manage IAM roles through the same console. We can also use the command line tools to issue commands to perform IAM and AWS tasks. For example, a lot of people are more comfortable using command line than using the management console, and they're also useful if you want to build scripts that perform AWS tasks. Now, Amazon provides two sets of command line tools. You have the AWS command line interface And you also have the AWS tools for Windows PowerShell. You can also access it through SDKs, which are software development kits that consist of libraries and sample code for various programming languages and platforms such as Java or Python. The SDKs provide a convenient way to create programmatic access to IAM and Amazon Web Services. For example, the SDKs take care of tasks such as cryptographically signing requests, managing errors, and retrying requests automatically. And lastly, you have the HTTPS API. You can access IAM and Amazon Web Services programmatically by using the HTTPS API, which lets you issue HTTPS requests directly to the service. Now, when you use this API, you must include code to digitally sign requests using your credentials. So just keep in mind these 4 different ways that we are able to access and configure IAM within AWS. Now, before you create users, you need to understand how IAM works. Now, it provides the infrastructure necessary to control authentication and authorization for your account. Now, it includes a number of elements. First and foremost, we have the principal, which is an entity that can make a request for an action or operation on an AWS resource. Users, roles, federated users, and applications are all AWS principal. Your account root user is your first principal, and as a best practice, like I mentioned before, do not use your root user for your daily work. After the principal, we have the request. Now, when a principal tries to use the AWS Management Console or the API or the CLI, the principal sends a request to AWS, and it can include a number of information, for example, such as actions or operations that the principal wants to perform, any resource object upon which the action or operations are performed, the user, the role, the federated user, or application that sent the request, environment data, such as the IP address, the user agent, or if SSL is enabled, or the resource data related to the resource that is being requested. And this could include information such as a database table name or a tag on an Amazon EC2 instance. AWS gathers the request information into a request context, which is used to evaluate and authorize the request. After the request, you have the authentication. And as a principal, you must be authenticated or signed into AWS to send requests to AWS. Now, although some services such as the S3, which is a storage service, allow a few requests from anonymous users, they are an exception to the rule. Now, to authenticate from the console as a user, you must sign in with your username and password. To authenticate from the API or the command line, you must provide your access key and secret key. You might also be required to provide additional security information, so just keep that in mind. For example, if you have multi-factor authentication enabled. So after authentication, we have authorization, during which AWS uses values from the request context to check for policies that apply to the request. It then uses the policies to determine whether to allow or deny the request. And most policies are stored in AWS as JSON documents and specify the permissions that are allowed or denied for principals. Now, there are several types of policies that can affect whether a request is authorized. And those policies can be categorized as either permission policies or permission boundaries. Now, the policies define the permissions for the object to which they're attached, and these include identity-based policies, resource-based policies, and access control lists, or ACLs. A permission boundary, on the other hand, is an advanced feature that allows you to use policies to limit the maximum permissions that a principal can have. After authorization, you have the action or operation, because after your request has been authenticated and authorized, AWS approves the action or operation in your request. Operations are defined by a service and include things that you can do to a resource, such as viewing, creating, editing, or deleting that resource. For example, IAM supports about 40 actions for a user resource such as creating, deleting, getting a user, updating a user, and so on. And finally, we have the resources. After AWS approves the operation in the request, they can be performed on the related resources within your account. A resource, again, is an object that exists within a service. For example, an EC2 instance is a resource. An IAM user is a resource. The service defines a set of actions that can be performed on each resource. If you create a request to perform an unrelated action on a resource, that request is denied. Now, since IAM is an integral part of AWS, there are some best practices that you need to keep in mind when you put into practice, and especially for the Cloud Practitioners exam, you need to keep this in mind as it relates to IAM. And like I've already mentioned, make sure you lock away your AWS account root user access keys, because if anybody gets access to them, they can basically go ahead and provision 10,000 EC2 instances on your account, and your company will be liable to pay for them. Next is create individual IAM users. Don't use your root user, don't give your credentials to anyone. Instead, you can create individual users for anyone who needs access to your AWS account. For example, first and foremost, create an IAM user for yourself and give yourself administrative permissions. Next, use groups to assign permissions to IAM users. Instead of defining permissions for individuals, it's usually more convenient to create groups that relate to specific job functions such as developers, administrators, accountants, and so on. After you do that, define the relevant permissions for each group, and then finally, assign users to those groups. Next step is use the AWS defined policies to assign permissions whenever possible. Now, there are a bunch of predefined policies that are already created for you by AWS, and it's always recommended that you try to use those, but obviously there will be some instances when they will not apply to your use case. Then you can go ahead and create and define your own policies, but in my experience, 98% of the time, you should be able to use policies that are already pre-built by AWS. Next step is grant least privilege. Now, when you create policies, follow the standard security advice of granting the least privilege. That is, granting only the permissions required to perform a task. Determine what users need to do, and then craft policies for them that let users perform only those tasks. Use access levels to review IAM permissions. To improve the security of your account, you should regularly review and monitor each of your policies. Make sure that your policies grant the least privilege that is needed to perform only the necessary actions. And when you review a policy, you can view the policy summary that includes a summary of all of the access levels for each service within that policy. So AWS does make it easy for you to review all the policies that you have created and used. So it's not a tedious task, but it is a task that should be performed by you on a regular basis. And the last two just pertain to a stronger security level, which is having a strong password policy, which you are able to define within IAM. And then lastly, the multi-factor authentication for privileged users to make sure that you identify all of the administrators that will be logging into your AWS account to ensure that only the people that are authorized and authenticated have access to it. Continuing on, some last few best practices to keep in mind. For EC2 instances, make sure that you use roles. Now, for applications that run on them, they need credentials in order to access AWS services such as storage services. And to provide credentials to the application in a secure way, use the IAM roles. A role is basically an entity that has its own set of permissions, but that is not a user or group. Roles also don't have their own permanent set of credentials the way IAM users do. In the case of the EC2, IAM dynamically provides temporary credentials to the instance, and these credentials are automatically rotated for you. Now when you launch an EC2 instance, you can specify a role for that instance as a launch parameter. You can use those roles to delegate permissions. Don't share security credentials between accounts to allow users from another AWS account to access resources in your account. Instead, use roles. The next one goes without being saying, which is do not share your access keys. Rotate credentials regularly, which is changing your passwords and access keys. And again, when you're doing the review, removing any unnecessary credentials that might not be required anymore or that were created and that should not have been created. Use policy conditions for extra security. And to the extent that it's practical, define the conditions under which your IAM policies allow access to a resource. For example, you can write conditions to specify a range of allowable IP addresses that a request must come from. And lastly, monitor. You can use logging features in AWS to determine the actions users have taken in your account and the resources that were used. The log files show the time, the date of actions, the source of an IP, which actions failed due to inadequate permissions, and much more. So it's very important that we regularly monitor our AWS activity. So let's go ahead and take a look at IAM and all the different features that we just discussed